In lesson 3, we're going to look at a third type of sequence is called a recursive sequence. So a recursive sequence is when the next term or a new term is generated from the previous term. So for example, if we had the numbers 1, 2, -1, 3, I'm just going to write them out up here. So let's say we had the numbers 1, 2, -1, 3, -4, 7, -11. This is a recursive formula because the third term is a result of subtracting the previous two numbers. Let's change color here. So if I do 1 minus 2, I get -1. If I do 2 minus -1, I get the next term, which is 3. If I do -1 subtract 3, I get the next term, which is -4. If I do 3 minus -4, I get the next term, which is 7. So there's no arithmetic pattern between the numbers, and there's no geometric, but there is a pattern where I can find the next term in the sequence by using the term before it. So when you get a recursive sequence, they will always give you the first term. So t to the 1 is the first term in that sequence. And then it will give you a formula to find the next term in the sequence. So this question wants us to find the first 4 terms. Well, we already have the first one, which is 2. So the second term, I'm going to use this formula here, t to the n. So the second term would be n is 2. So I'll put the 2 in there. Well, 2 minus 1 is 1. So in order to get the second term, I'm going to do 3 times the first term and then add 5. So I know the first term, it was given as 2. And so the second term is 3 times 2 is 6 plus 5 is 11. If I want to find the third term, I'll put it in the formula. So now n is 3, so it'll be 3 minus 1. Well, 3 minus 1 is 2. So to get the third term, I'm going to multiply 3 by the second term, so the term before it that I just found was 11, and I'm going to add 5. So that's going to be 38, so that's the third term. And I'll do one more, so the fourth term is going to be 4 minus 1, so 3. So to find the fourth term, I'm going to do 3 times the third term, which we just found to be 38, and we're going to add 5. So each term in the sequence depends on the term immediately before it. Okay, so again, here's another example. Find the first 4 terms. So it gave us the first term. t to the 1 is 4. Then they give us a formula for the rest of the terms. So t to the n, so the second term will be -3 times n minus 1. So if n is 2, 2 minus 1 is 1. So to find the second term, we're going to do -3 times the first term, which we know is 4. And that's going to give us a value of -10. Then we're going to find the third term. Well, 3 minus 1 is 2, so it will be -3 times t to the 2 plus 2. And we just found t to the 2 to be -10. And so that equals 32. And then we're going to find one more term. The fourth term will be -3. 4 minus 1 is 3, so -3 times the third term. We just found the third term to be 32, and so that works out to be -94. So in general, when calculating the nth term of a sequence without knowing any previous terms, this is called an explicit formula. We have also called this the general term for the arithmetic. So arithmetic sequence, the explicit formula, or the general term, we know as t to the n equals the first term plus n minus 1 times the common difference. In a geometric sequence, the explicit formula, or the general term, we know as t to the n, a first term, multiplied by a common ratio n minus 1 times. Then we have an arithmetic recursive explicit. So we would be given the first term as a, And then the general term or the explicit formula would be t to the n minus 1 plus a common difference. And the geometric would be t to the n minus 1 times a common ratio. So here's my formula for explicit, recursive, and then the explicit is what we have normally here. So the recursive will be this one, and then the explicit will be these ones. So let's look at an example. I'm going to do question 3. Question 1 and 2 are just some practice finding the first 4 terms in the sequence, just like we did. And you'll see that the answers are at the bottom here. So you can do those as practice and then check that you're getting the right answer. So let's just look at number 3. So number 3 says determine a recursion formula and an explicit formula for the following. So here's the numbers given. So I can see that there's a common difference of 6. So they're going up by 6. So it's an arithmetic sequence. And so what I'm going to do is write down t to the 1. T to the 1 is the first term, which is 5. I want to figure out the explicit or general formula. So I know t to the 2 will be equal to t to the n minus 1 plus some difference. So the second term is 11, t to the n minus 1, and I know they're going up by 6. And then the third term will be, that's minus, the third term, well, let's just write the number in. So the third term is 17, so that's going to be t to the n minus 1 plus 6. So I can see that the explicit formula will be t to the n plus a common difference of 6. So you'll see the answers here. 3a, the term in a sequence is t to the n minus 1 plus a common difference of 6. And then if I want to find the second thing it wants me to find is the explicit formula. So this is the recursion formula. And then the explicit will be similar to what we did with the arithmetic sequence. So t to the n equals a plus n minus 1d. So we know that the first term was given as 5. We know that it has a common difference of 6. And so the explicit formula will be 6n minus 1. And so you can just look here to look at the form. I've given it up here in the, oops, let's look at the previous